For this next problem, once you see n's in your functions, we're talking about arithmetic sequences. Also, if we keep in mind when the arithmetic sequence, the generic formulas are, we would know that that's what this is referring to. So for this problem, they give us the first term. Remember, if you're given the first term, that automatically means you're working with a recursive rule because you have to know the first one in order to find the next. Our goal is to find the fifth term. So I'm going to put 1, 2, 3, 4, 5 here. First term is 3. So this is f of 1. This is going to be f of 2, the second term. The third term, f of 3, the fourth term, f of 4, and the fifth term, f of 5. Remember, n means the position number. So we're talking about the third, the sixth, the 10th, the 100th position. That's what n means. So now that I know what the first one is, this here also tells me all we're doing is taking whatever the last term is. So I can replace this with the last term that we solved for, right? Last term we solved for. So if I do that, I'm going to be able to find it because that's what f of n minus 1 is, and I'll show you why. So if we take, let's say we're trying to find our second term. I'm going to take f of 2, right, because that's what we're trying to find, and negative 2 times f of, so times, I'm going to put brackets instead, f of, what is that, 2 minus 1 plus 1, right? So ignore the brackets, but essentially I'm just writing out what it is. Actually, let me just make it cleaner so I don't confuse you. So f of 2 equals negative 2 times f of 2 minus 1 plus 1. We know what 2 minus 1 is. 2 minus 1 is just 1. So that's going to be f of 1, right? That's being multiplied by the 2, and then we're adding 1 because of order for operations. So pretty much f of 1, right? We're on 2, but this is saying f of 1, which was the last term we solved for. Technically, we didn't solve for it because they gave it to us, but it's the same idea. So essentially, what this entire function rule is telling me is that if I take the last term I had and then multiply it by negative 2 and then add 1, I'm going to find what that answer is. Remember, order of operations, so I need to multiply before I add. F of 1 was 3, so 3 times negative 2. If I plug that in for you, 3 times negative 2 is going to be negative 6, and negative 6 plus 1 is going to be negative 5. So that means our second term is going to be negative 5. Now, I already know based on the function rule that I'm going to be multiplying by negative 2. My last term, I multiply that by negative 2, and then I'm going to be adding 1 after that. So if I take negative 5 and multiply it by negative 2, that gives me positive 10, and 10 plus 1 is 11. Found my third term. The fourth term, that means I need to take 11, the last term we solved for, multiply by negative 2, which gives me a negative 22. Add 1 to it, so negative 22 plus 1 is going to be negative 21. One more time, to find my fifth term, go back to the last one we just solved for, negative 21. Multiply that by negative 2. Negative times a negative is a positive, so 21 times 2 is 42. Add 1, we get 43. So the answer to this is going to be D. If we take a look at this next problem, this next one is a gimme. These are easy questions because there's things we know automatically to look for. We're trying to look for the table that represents a function, right? Remember, if your x's don't repeat, it is automatically a function because you don't have to worry about looking at the y values. You're always concerned with x first. You're only ever looking at the y values if one of your x values repeat. So for here example, I have a negative 3 here and a negative 3 here. Now the first time it went into that machine, 8.5, positive 8.5 came out. So the second time it should be positive, but we see it's negative. So it's not A, right? Because the y values when the x repeat did not stay the same. If you notice here, all of these are negative 2, and we have a whole bunch of different values for y. that's not going to be our answer. We take a look at D. We have -5 that repeated, and we also have -8 that repeated. So it doesn't matter that we have two different ones. Pick the first one that repeated, -8. That came out with a -7 the first time, but the second time we put it in, it was a 12, right? So then that means it's not a function. Obviously, if you look at the -5, the y's values don't repeat either. But the first time you have a repeating x and that doesn't match up the way it's supposed to, it's automatically not a function. So last but not least, it can only be b, because if you notice, b does not have any x values that are repeating, so it's automatically a function. This problem here, what is the value of f of 16 minus f of 0 when f of x is equal to 4x minus 8? Now understand, we're not talking about n's. So remember, arithmetic sequences in general, you're talking about n. N stands for the position number. Here, we don't have n. So we're not talking about the sequence, right? We're talking about just a regular equation, trying to find our y's. We have x and y values. Now, this one is key. It says f of 16 minus f of 0. We have to figure out what is that. Now, we don't know right away, right? You can't just take f of 16 and subtract 0 from it and get 16. That's not how that works. Remember, f of whatever means a function of. So that means this, the usual way we write it is f of x. F of x is the same thing as y. So we're trying to find our y values. Now, the thing that we're given already that they don't explicitly tell us we're given is we know two x values. Two of our x values, one of them is 16, the other one is going to be 0. We found that because of the numbers we see inside the function. Because remember, usually we have x. So since x isn't there, remember our independent variable, since x isn't there and they replace it with numbers, that means that's what x is equal to. But that all still doesn't help us unless we recognize that we need to take a look at this function, this equation. If we look at this equation, that's going to be what helps us to find our y when x is 16 and to find our y when x is 0. Remember, think of it as an xy table. What we're trying to do is we need to figure out what is the y value when x is 16, what is the y value when x is 0. So to do that, I'm going to take 16 and rewrite the equation, but everywhere I see an x, I'm putting 16 in instead, because that's what x stands for. So 4 times 16 minus 8. 4 times 16 is 64 minus 8, and 64 minus 8 is going to be 56, okay? Remember, 4x minus 8 is the entire equation. So all I'm doing is plugging in 16 and solving. So all we solve for right now is f of 16. We got one part down. Now the last part, we got to substitute in 0. So f of 0, let's see if I can squeeze it in here, is equal to 4 times 0 minus 8, right? Because all I did is I used the original equation and plugged in x for 0. So anything times 0 is 0. So 0 minus 8, and 0 minus 8 is just -8. So f of 0 is equal to -8. We're still not done. We now know what f of 16 is, and we now know what f of 0 is. So if we go back to the original problem that we were asked, we had to take f of 0, whatever that, f of 16, whatever that y value is, and subtract the y value from f of 0 for it. So f of 16 is going to be 56, which we got here. I'm going to put 56 minus f of 0 was -8. So remember, f of 0 is -8. So that minus sign doesn't take care of that -8 part. Anytime you subtract a negative number, it's the same thing as adding a positive. So 56 plus 8 is going to be 64, and your answer is going to be D. If we take a look at this problem, Vincent goes to the gym for 30 minutes every day. He starts a new exercise routine on a Monday and uses a function to model the amount of calories he has used. And the amount of calories he has used, we're representing that as f of D. So f of D is equal to the amount of calories he has used. It's a function of the number of days, which is D. So D stands for days, but F of D stands for the amount of calories he has used. So we need to figure out which one of these statements represents the correct interpretation of F of D. So once again, all this is, you have to understand what the parts of your equation mean, what the parts of your function mean. So if we take a look here, F of 5 equals 150 means Vincent has exercised for a total of 150 minutes after the 5th day of exercising with his new routine, right? So remember, D stands for days. So as far as the 5th day is concerned, that's correct. But 150, right? Whatever F of D is equal to, whatever's after that equal sign, it doesn't stand for minutes. It stands for the amount of calories used. So it's not going to be A. F of 10 equals 3,500 means Vincent will use 3,500 calories on day 10 of exercising with his new routine. Now that makes sense. 10 is inside where D was, and that represents days. And then remember, the amount of calories he has used is what F of D represents. Whatever D ends up being, we're going to talk about the amount of calories used. And that's what they have here. So right here, we know that B is going to be the correct answer. Obviously, if you check the next two, remember, anytime they're referencing the number that's inside here, they have to be referring to the number of days. Anytime they're referencing to anything to the number out on the right-hand side of the equation, it's got to be talking about the amount of calories he was using. So B is our answer for this. Second and last question. So which statement below is correct for the following set of ordered pairs? Now, I always say I don't like how it's written in one line because sometimes that's confusing. So right away, I'm going to draw an XY table and rewrite it so it's easier to see. So I have 0, 1.2, I have 3 and 2, negative 1.2 and 3, 4 and negative 2, 1 and negative 1.2, and then 2 and 4. Okay, now I need to read through the answer choices. So A says the set is a function since each element in the domain has a different element in the range. The set is a function since each element in the range has a different element in the domain. The set is not a function since each element in the domain has a different element in the range. And the set is not a function since each element in the range has a different element in the domain. So pretty much our answer choices are trying to get us to say, is it a function or is it not a function, right? And based on, is it because the domain has a different element in the range, or is it because the range has a different element in the domain? Now, remember, function, if it's a function, you're always looking at your x. Remember, x is the same as domain. And I always tell you, you're focused on x values. You only ever look at your y's, your range, if you have a repeating x. If you look here, none of our x values are repeating. So we know it has to be a function. So it's not going to be C or D. And now remember, it's based on the domain having a different element in the range, right? Because if our domain repeats, if we have a repeating x value and the y value for that, the range for that domain is not the same, then we know it's not a function. So it's always based off of domain. So it's going to be A, because B is saying that it's based off of the range having, which means we would focus on y, and that's not the case. We focus on x. Last question. A store manager begins each shift with the same total amount of money. She keeps $200 in the safe and distributes the rest equally to the 5 cashiers in the store. This situation can be represented by the function y equals x minus 200 divided by 5. They want to know, what does the variable x represent in this situation? Does it represent the total amount of money the manager has at the beginning of a shift, the total amount of money the manager has at the end of a shift, the amount of money each cashier has at the beginning of a shift, or the amount of money each cashier has at the end of a shift? So we need to understand, once again, the parts of our equation, the different terms, what the terms mean. So if we read it again, a store manager begins each shift with the same total amount of money. She keeps $200 in a safe and distributes the rest equally to the 5 cashiers in the store. This situation can be represented by the function. So of the same total amount of money, each shift starts with the same amount of money. So that's one piece of information we need to know. The $200 is what she's taking out of the total amount of money to put into the safe. So if she's keeping $200 of that total amount of money, that means she's subtracting the $200, which is what we see represented right here. So now, what is she subtracting that 200 from that we said? She said she's subtracting it from the total amount of money at the beginning of each shift. So the only ones that are talking about the total amount of money are A and B, so we can eliminate C and D. But remember, this is the total amount of money at the beginning of each shift. So that's going to leave us with A. And that's the answer for that problem.